Hey guys, today we're going to look at graphing exponential functions and transformations of exponential functions. You're going to need to make sure you have a calculator. You're also going to make sure that you have maybe a different color than your pencil or a highlighter or something like that, because these graphs are going to have asymptotes and you're going to want to make sure those asymptotes really stand out. So our exponential parent function is f of x equals b to the x power, b is any number. If b is greater than 1, the function is an exponential growth and is increasing. If b is less than 1, the function is an exponential decay and is decreasing. An asymptote is a line which the graph gets close to but never crosses. So as you can see here, we have some functions we're going to graph and then some characteristics that we are going to fill in based on what we see. So y equals 2 to the x power. And you might want to use your table because we want to get these graphs as accurate as we can. Notice your asymptotes don't show up there. All right, 0, 1, 1, 2, 2, 4, 3, 8. And then below 0, it's just really, really small. So our asymptote is our x-axis. And you need your asymptote as part of your graph. And when you draw your graph, try your best not to touch or cross that asymptote. So as you can see, we have no restrictions on our domain. Interval notation, our range is above the x-axis, but doesn't touch it. As x approaches infinity, our graph approaches infinity. And as x approaches negative infinity, our graph approaches 0. Our y-intercept is 0, 1, where it crosses the y-axis. And our asymptote is y equals 0, which is our x-axis. Make sure your asymptote is an equation and not just a number. All right. At any point, you can pause the video and try some of these on your own. So y equals 3 to the x power. As you graph it, you can see that your asymptote is again the x-axis. And at that point, you're welcome to go ahead and fill in your characteristic. Using our table, we have again 0, 1, so there's our y-intercept. 1, 3, 2, 9. So this one's going to grow a lot faster than problem number 1 because my base is bigger. Again, your domain has no restriction. Your range is greater than 0. Your end behavior as x approaches infinity, your graph approaches infinity. And as x approaches negative infinity, your graph approaches 0. So there are 3 problems on the back of this sheet. I would like for you to pause your video, work on those 3, and then come right back. All right, guys, welcome back. Let's see what you guys got for some of your answers. Mark your questions where you have them. Notice how clear the asymptote is on the graph. Make sure yours stands out as well. For number 3, domain, negative infinity to infinity, range 0 to infinity. As x approaches infinity, f of x approaches 0. And as x approaches negative infinity, f of x approaches infinity. Y-intercept at 0, 1, asymptote at y equals 0. Number 4, notice it's also a decay, but it's a little bit flatter. That's because of your value in parentheses. So your domain, negative infinity to infinity, range 0 to infinity. As x approaches infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches infinity. Y-intercept 0, 1, and asymptote y equals 0. Back to a growth function for number 5, domain negative infinity to infinity, range 0 to infinity. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches 0, y-intercept 0, 1, and asymptote y equals 0. Taking a look at transformations of exponential functions, that equation looks like this, where you have your a value out front. That lets you know if you have a stretch or compression. Your exponent has included an h, which is your horizontal shift left or right. Your k out to the side is your vertical shift, which moves up or down. So we're going to identify the parent function in the transformations for problems 1 through 4. So the parent function is f of x equals 3 to the x power. The plus 5 means you move up 5 for your transformation. Problem 2, part A, f of x equals 1/4 to the x power. We have a vertical stretch of 2. And we are going right 1. And that doesn't need a C. It's just a continuation of part B. Number 3, f of x equals 4/3 to the x power. Transformation, you have a reflection over the x-axis. You're moving left 2, that plus 2 in the exponent, and you're moving up 7 because of the positive 7 outside. Parent function for number 4, f of x equals 5 to the x power. Transformation, you have a vertical compression of 1/2. You're going right 4 because of your exponent, and down 2 because of your number to the outside. Again, make sure you have asymptotes clear for the graphs. Make sure you fill in your characteristics. So going to our graph, y equals 2 to the x plus 5 power, you should be able to identify that this graph is going to be moving left 5, and your parent function is f of x equals 2 to the x power. So this is going to be a growth function. And you should be able to see that your asymptote is y equals 0. You should also know that if we have been shifted to the left, that our graph is also shifted to the left in our table. It's going to help us put some of those points on the graph. So -6 1/2 and -5 1 and -4 2 and -3 4 and -2 8. So there's your graph. Your domain has no restriction. Your range is above the x-axis. As x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches 0. Your y-intercept is 0, 32. Look in your table. When when x is 0, what is y? That's going to be your y-intercept. All right, I would like for you guys to pause your video. I'd like for you to work on problem 6 through 9 on the back, then come right back and check your answers. Also make sure that in this blank space that you are writing down the transformations that are occurring in each particular equation. All right, welcome back. Taking a look at number 6, your graph has moved down 2, and notice by doing that, your asymptote moves down 2. So your asymptote is now y equals -2. Domain, negative infinity to infinity. Range, -2 to infinity. As x approaches infinity, f of x approaches -2. As x approaches negative infinity, f of x approaches infinity with a y-intercept of 0, -1. A shift down 2. Number 7 is a vertical compression of 1/2 and up 1. So here's what your graph looks like. Your domain, again, negative infinity to infinity. Range 1 to infinity. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches 1. Y-intercept 0, 1.5. Asymptote y equals 1. For number 8, you are moving right 4 and down 5. Your domain is negative infinity to infinity. Your range is -5 to infinity. Your end behavior as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches -5. Y-intercept you're going to need to get directly from the table is 0, -4.802. Asymptote is y equals -5. Number 9 is a reflection over the x-axis. Notice what happens to your graph when that happens. You have a vertical stretch of 2, and then you move right 2. So your domain is negative infinity to infinity. This time your range is negative infinity to 0 because it's all the way down here until we get to the x-axis. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches 0. Again, y-intercept from the table, 0, -0.125, and your asymptote is 0. This concludes our section on graphing. If you have any questions, let me know, and I hope to talk to you soon.